Hi everybody, hi, Mike here, and it's time for another lesson on KSP. If you remember where we left off, we were going to have you write the expression for the KSP of aluminum hydroxide, which by the way is in the antacid, the old-timey antacid, Rolaids. So nonetheless, what we're going to do is we're going to write how this ionizes in water, which is aluminum. My kid is laughing. What the hell is so funny? Now you're getting in it. He's eating ramen noodles.
Don't look at me.
Okay, I won't get your face in it. My kid is eating ramen noodles and she thinks this is funny. Hold on. I'm back. And so anyhow, we're going to write how this falls apart in water, which is that the solid goes double arrows. This is partially soluble. Makes aluminum 3 plus 3 OH minus. KSP is products over reactants. But there are no reactants in the expression because the reactants are solids. So this is going to be OH minus cubed. Now how's that going to play out? Because what we're going to do is we're going to solve problems with this later. What if we call this would be negative x, this would be plus x, this would be plus 3x. So when this stuff dissolves, there's going to be 3 times as many hydroxide ions as aluminum ions because of the ratio in the formula. If we plug this in, this is going to be x times 3x cubed. What's 3x cubed? Well, anyhow, this is all equal to the value in your table. So let's look it up. Hydroxides are right here. There's aluminum hydroxide, 5 times 10 to the minus 33. That's all equal to 5 times 10 to the minus 33. Anyhow, 3x cubed is 3x times 3x times 3x, so that's 27x squared times x. Hope I don't lose anybody. Make a comment if I do. This is x times 27x cubed is equal to 5 times 10 to the minus 33. And then this would be 27x to the 4th power is 5 times 10 to the minus 33. Let's do a little bit of order operations, right? Let's go and find x. That would be x to the 4th power is if I divided both sides by 27. So on our calculator, 5 times 10 to the minus 33 divided by 27 is 1.85 times 10 to the minus 34. And so now here's what we got to do, folks. I'm going to do a 4th root. I got a y to the x button. And what I could do is I can go y to the x 0.25. I got to do both sides to the 0.25 power, which is 1/4 power. And then I get as a result x, which is the stem of every problem, like the one that's going to come next that you can just get a peek at. X is equal to 3.69 times 10 to the minus 9 moles per liter. What does X mean? X means how many moles per liter this would dissolve. X means the concentration of aluminum ion. X is actually 1/3 of the hydroxide ion because the hydroxide ion concentration is 3x. So if we answer the next question, think about the next question before we answer it. What's the pH of this solution? Well, it's going to be greater than 7. This is a basic salt. And let's go figure out what that's going to be. Okay, so concentration of OH minus equals 3x. We proved above that x is 3.69 times 10 to the minus 9 moles per liter, so this would be 3 times 3.69 times 10 to the minus 9 moles per liter. 1.10 times 10 to the minus 8. 1.11 times 10 to the minus 8. And I kind of did a little trick question here. If we do a log of that, the negative log of that is 7.95, but let's not even continue. This stuff is so insoluble that the amount of hydroxide ion in the solution is less than that provided by pure water. So the funny thing is, the pH of the solution is actually 7. If you took a hydroxide and you put it in water, it better dissolve to the tune of greater than 1.0 times 10 to the minus 7 moles per liter for it to even push up the pH past 7. Okay? So think about that. It's kind of weird. It had to have a KSP large enough that it would supersede what water does. Let's think about the next thing. This will be a better, more practical question. How many grams of aluminum hydroxide would dissolve in a 2-liter bottle? We'll solve that one next. Okay guys, now you got to remember, what does X mean? X in every problem, minus X, is the amount in moles per liter of the salt that will dissolve. So we're going to start with X. 3.69 times 10 to the minus 9 moles of aluminum hydroxide, 1 liter. Now we got to do good old Gen Chem 1. 1 mole of aluminum hydroxide, certain number of grams of aluminum hydroxide. Get our handy periodic table out. Pause. Speaking of pause, there's my cat. Hey cat, say hi to everybody. Hey. I'm not going to tell you his name because I don't want you to stalk him online.
Throw him colors.
Throw him a treat. Yep. And I'm back. Aluminum hydroxide's molar mass is 78.01 grams. And don't forget, we're calculating this for 2 liters. So we got to multiply. This would be, if we just stopped at this step, this would be how many grams per liter. But we want to know per 2 liter. So let's crunch that number out. 3.69 times 10 to the minus 9 times 78.01 times 2 equals 5.776 times 10 to the minus 7 grams. So what would that be? That's a little bit more than a half a microgram would fit in, would dissolve into a 2-liter bottle. You know what a 2-liter bottle looks like, you soda drinkers, you. So this is 0.5676 microgram. Small number. barely something you could even see. You know, it's a less than 1,000th of a paper clip. It would be a millionth of a paper clip in mass. Ready for our next problem? One more. I'm going to leave it hanging for you to finish the next part, see how we do next time. There will be one more video on KSP, and then we're ready for exam 3, folks. Write the KSP expression. You know what? I'm going to go ahead and solve for X too, for barium phosphate. All right, this one gets a little weird. The more ions there are, it gets weirder. Barium phosphate. Remember that phosphates are, well, back to good old Gen Chem 1 like we always are. Barium being in group 2 makes a positive 2 ion. This would be 2 PO4 3 minuses is what a phosphate is. We're going to go ahead and call KSP equals the barium concentration cubed times phosphate concentration squared. Let's go dig up what that number is. That number from your chart, phosphates are down here at the bottom right, is 6 times 10 to the minus 39. It's kind of small. It's very small. I mean, it's not very soluble. Now, back up to finding X, right? Minus X. See the pattern there? You always can figure out how much of something dissolves from minus X. Plus 3X plus 2X. Plug it all in here. 3X cubed times 2X squared equals 6.0 times 10 to the minus 39. So I'm going to leave it there. And I'm going to tell you what our question is going to be for next time. And then we'll have another question which is a little bit different. How many grams of barium phosphate would dissolve in a 55-gallon drum? Many of you have probably seen a 55-gallon drum. There's about a gallon's a little bit less than a little bit more than whatever. It's about 1/4 of a liter, 4 liters per gallon-ish. So let's calculate how many grams of that. If you were to put it all into a 55-gallon drum full of water at room temperature, how much of that stuff would dissolve? Hang in there, guys. Ask questions. Don't let me lose you. All right? Next time, we're going to finish that problem, and then we're going to do a thought process where we think of whether we can predict if something's going to precipitate or if it's not, if we added two things together and maybe made a precipitation reaction. So we'll use KSP to predict the outcome of a precipitation or a not precipitation. See ya!